Hello and welcome everyone. You are logged into the Fighting Flicker webinar series. Thank you for joining us today. Everything we see, most of what we do, and a lot of what and how we feel is touched by lighting. Vision is our most powerful perceptual sense, and we use lighting to control much of this. Today, our panel of speakers will discuss something that can be quite annoying when you're exposed to it. We will be discussing the causes and effects of flicker in lighting. Just a couple of house rules before beginning. All attendees are in listen-only mode. Therefore, the best way to communicate with us is by using the chat box located in the bottom corner of your screen. When you send a chat question, only the speakers and our energy focus engineer, Greg Fleece, will be able to see these chat questions. And we will respond directly to your question. So it won't be broadcasted to everyone here. There will be a Q&A session towards the end of this webinar where the commonly asked questions will be presented to the speakers. So feel free to utilize that chat question at any point during this webinar. Let's take this time to talk about our speakers. From Energy Focus, we have John Davenport, who is a recognized global expert in light source physics and product technology. Starting his career at GE Lighting as a research scientist, John developed numerous advanced lighting products for GE, including something we might see every day, those blue xenon headlamps currently used in cars. Over the past 18 years with Energy Focus, John has led the development of a range of LED lighting products, including our IntelliTube, which is our unique tubular LED retrofit technology. He is the author of more than 125 patents, and he currently serves Energy Focus as the company's chief scientist. Welcome, John. Also from Energy Focus is Laszlo. Hi, John. Sorry about that.
Yeah, I'm here. No problem. It's great to be here. Thank you.
And also from Energy Focus is Laszlo Tackas, who has designed a wide range of optical and electro-optical control hardware and software in support of the lighting industry since 1996. In 2011, Laszlo designed the first microprocessor-controlled intelligent lighting for Energy Focus's advanced fluorescent replacement lamps, which can analyze their control environments and actually, according to that, control that environment. He is also the architect of Sora's flicker-free MR16 electronic package, which is also the most highly miniaturized and efficient flicker-free MR16 driver on the market. He currently serves Energy Focus as the company's CTO. Welcome, Laszlo.
Hello.
And I am also very pleased to introduce Naomi Miller as one of our speakers today. Naomi straddles the line between design and engineering as a senior scientist at the Pacific Northwest National Laboratory. She researches and reports on lighting issues such as visual comfort, flicker, and light distribution with respect to the solid-state lighting products. By bridging the gap between technology and application, she can truly promote the wise use of LEDs, working with our lighting industry to overcome the hurdles and celebrate the opportunities. She serves as the Illuminating Engineering Society's Board of Directors and as both a fellow of the IES and the International Association of Lighting Designers. Very good to have you, Naomi.
Thanks. Glad to be here.
And my name is Yumi Alinoli, and I am the Product Marketing Manager at Energy Focus, and I will be your moderator for today's webinar. With over 10 years of experience in the energy industry, I strive in finding the best ways to provide an audience with knowledge-based solutions through communication and technology, very much like what we're providing during today's webinar. So now that you know a little about the speakers, let's get to know a little more about our audience. Throughout the actual webinar, I will be presenting a couple of poll questions. And the first one is, what industry do you work in? And you do have a couple of options to choose from. And so go ahead and please feel free to choose one. If one does not qualify under the industry that you work in, please go ahead and select Other. And I'd like to take this time to ask you, if you do select Other, go ahead and put what other industry you're working in the chat box. We'll take a couple of seconds here. I do see all of the results coming in. And as you do click on your result, you will see the results as well of the rest of the participants in our audience. And I do see a bunch of chats coming in as well, so it's great to have this form of communication. I'm going to go ahead and skip to the results right now. And as we can all see, there's a good amount of industrial attendees, and also quite a bit of commercial and other. So feel free to send in what other industry you are in, and I'd be happy to connect some of those examples during today's webinar. Thank you, everyone, for participating. Another question that I'll send out to you is, what job role best describes you? I know we all wear many hats here, but you can only select one, or you can select Other and explain that type of role that you're in. So go ahead and participate in this poll. Okay, I'll give it a couple more seconds, and I'm going to skip to results now. Other, wow. Okay, and I see a lot of distribution representatives coming through the chat box here, with a lot of managers, engineers, specifiers. It's really great to get a sense of who is in our audience. Lighting control specialists. There's plenty of chat answers coming in. So I'm glad to see that. And the very last question, what type of lighting are you currently using? All right, I'll give it a couple more seconds. And I'm going to skip to results. And I'm very pleased to see that almost 80% of the audience is using LED lighting, followed by fluorescent lamps with ballasts. Very good to see, and there will be plenty of examples that will be touching upon between fluorescents, LEDs, even some of our conventional lighting. Thank you, everyone, for joining this poll. And now I will go ahead and talk about our agenda. We will be touching upon 5 major things today, where we will start off with what Flickr is and continue to why we should care about what Flickr is. Why does it affect us? And then go on to how do we verify that we are under flickering lights. And once we understand that, what can we do about that? And then again, as I mentioned before, the very last section will be a Q&A session. So feel free at any time to send in some questions with your chat window. As a reminder, this presentation is being recorded, and the recording and these slides will be made available on our website, probably following the webinar or one day after the webinar. You will get an email about this as well. All right, so to start off, Naomi, how would you define Flickr in lighting?
Well, I'm going to start out by saying that Flickr is a generic term to describe different phenomenon, but it basically describes changes in light output over time. Sometimes that's visible, sometimes it's not. And that change in output over time also depends on how frequently the light output changes. So first I'm going to say that the umbrella term for Flickr is actually a temporal light artifact, which is a response, a change in visual perception induced by a light stimulus, a temporal light modulation, if you will. And that depends on the luminance or the light output changing over time, or sometimes it's a spectral distribution that fluctuates with time. So the three main categories are, first, visible flicker, which ranges from about 3 hertz up to 80 hertz. And that's a perception of visual unsteadiness. You can actually look at a light source and see it oscillating in light output. And that's for a static observer in a static environment. And it's really the luminaire that is turning on and off visibly. That's the portion that we worry about for seizure and epileptic responses, for example. The next category is stroboscopic effect, which is the change of motion perceived for a static observer in a non-static environment, and that ranges between about 80 hertz and 2,000 hertz. We have all seen in a discotheque the jerky motion that can happen when somebody is moving in a strobing light source. So that's an extreme form of this effect. So the third category is called the phantom array effect, or also called the ghost effect. And you are most likely to have seen this when you're driving at night, following tail lights on a car where the manufacturer has used pulse width modulation to reduce the output of the tail light by basically turning that stop light, or that the tail light on and off very, very rapidly in order to effectively dim it. So that is a perceived change in the spatial layout of the object for a non-static observer. And it sometimes looks like bunny tracks in the snow. Basically, you'll see an image of the light source, and as it travels over space or as your eye moves relative to it, you'll see a series of dots or a series of dashes that represent the light being on and then alternately off. And that ranges from about 80 hertz up to 2,500 hertz. Now, there's an additional definition that the IEEE P1789 committee came up with, and that encompasses everything I've just described here with one additional change. And that is that it was looking at the health effects of light, like are you picking up this flicker neurologically? And the reason is not all flicker is visible. Sometimes it can affect you neurologically without your being aware that that flicker is even there. So that encompasses the health effects on top of the lighting modulation phenomenon.
Okay. And when we're talking about what flicker and lighting is, why should the audience care about flicker and lighting?
Well, some of you may have heard of the CFF, which is the critical flicker fusion frequency, basically saying that if you're looking at a light source and it's oscillating in light output or flickering faster than about 50 to 90 cycles per second, that this is no longer perceived. You don't see it as flicker, and therefore it doesn't matter. Well, unfortunately, even if you can't see the flicker, it is still detected by your nervous system as modulation in light. And both visible flicker and this imperceptible flicker can have a negative impact on our physiology of our brain and cognition. And there are 6 chief reasons we get nervous about flicker. The first one is neurological problems, such as epileptic seizures that can take place when people are exposed to flicker. Now, fortunately, the number of people affected by photosensitive epilepsy is very small. It's about 1 in 4,000. But you will occasionally hear about people going to a theatrical performance or to a movie where there is flicker or strobe effect on stage. and it will cause that individual to either freeze or go into a seizure watching it. That's the kind of thing that can be very hazardous. Seizures are, they affect your memory, they can affect your brain function temporarily. It's a dangerous thing. The next one is headaches and fatigue and blurred vision and eye strain, just basically discomfort. The third one is migraines. Now, current statistics are that about 25% of the population experiences migraines at some point in their lives, mostly when you're a teenager, but even some teenagers grow older and continue to have the migraine problem over time, over their lives. Migraines are debilitating. They prevent you from being productive. Many migraine sufferers have to go into a dark room and just lie quietly for some period of time until the migraine goes away. So that's why we are very concerned about that. It's not just comfort, but it takes out your period of productivity. And then we also know from a number of studies that flicker, if you're working on your computer screen or if you're reading a book, for example, flicker actually affects task performance. So it can actually slow down your ability to read, for example. We also understand that flicker can increase autistic behaviors among children, and that can be a problem for teachers as well as for the children themselves. And then there's plain old-fashioned distraction. So all of these are things that flicker can cause, not in everyone, in a smaller subset of individuals, but they can be serious concerns. And that's why we're having this webinar.
Yeah, and Naomi, I'd also like to, sorry about that, I just wanted to point out on that previous slide, there are definitely more studies that are being presented and released about the effects lighting can have on children in classrooms that are exposed to the autistic spectrum disorder. In fact, we actually did a study ourselves about how flicker does affect children under fluorescent lighting and what happens to their behavior after that fluorescent lighting is upgraded to LED lighting. These are things that are documented and that are researched in real time today. So flicker not only affects just how this kind of proves that point, that flicker not only affects us because it's an annoyance, but it can affect us even more when it just debilitates the way that we can actually do normal things. And just because it doesn't happen to us doesn't mean it doesn't happen to somebody else. So if you would like more information on that, feel free to let us know, and we can definitely send you some more information. But thank you for bringing up these key points, Naomi. Please feel free to continue.
Yeah, thank you, Yumi. I will just add one point of clarification, and that is that not all fluorescent lights flicker. If they're operated by good quality electronic ballast, it operates at a frequency of sometimes 40,000 or even higher hertz. And even though there's a little bit of ripple on top of that due to the 60 hertz distribution, very few people are affected by electronic ballast. However, that's not true of older magnetically ballasted fluorescent, which did exhibit flicker, and if those luminaires in a school have not been upgraded, certainly that is exposing children to flicker. Not just the children, but their teachers as well.
The staff, yeah.
So, good point, Yumi. I'll just add two more things. Flicker can affect safety, and especially in an industrial setting. I was warned from the days I was a baby lighting designer that if I was designing an industrial space using metal halide or high-pressure sodium, there is a degree of flicker in those lamps, magnetically ballasted products. So we would alternate luminaires on three phases of alternating phases of the three-phase distribution system in the building, so that you would get overlap of light from adjacent luminaires, and that would mitigate the flicker, the depth of modulation of the light. And the reason for the concern is if you don't do that, there can be an interaction between the machinery that may be moving or moving laterally and the light, making that machinery look like it's moving at a different rate or even standing still. And there have been industrial accidents where someone has stuck their hands into a machine that looked like it was motionless, but it was actually moving, and that can cause an injury. So certainly we want to avoid that. And then in nighttime driving, the phantom array effect that I described can really distract a driver from seeing the really important details ahead of him or her on the driveway or on the roadway, or coming onto the roadway from the side. So that is the reason why we're concerned about flicker at nighttime from cars as well.
Yeah, and I assume that that flicker is impacted by the street lights at some point as well?
Not so much. The street
Okay.
lights, very few LED street lights flicker, fortunately. I've only seen a very small number of them that do. So it would probably be a rare situation.
Okay. Now that we're talking about some of the electronics, Laszlo, how would you think flicker would affect some electronics that we're commonly using?
Well, it's kind of interesting, Yumi. At very high frequencies, which might actually be out of the visual range, even above the 2500 hertz where it tends to get less attention, electronic devices, especially optical scanning devices, can pick this kind of interference up and cause them to malfunction. And the classic case is the barcode scanner. I've heard of a case of a grocery store that installed some LED lighting over the checkout area, and apparently, I'm going to guess that lighting didn't filter out the very high frequency component of flicker, probably in the multi-kilohertz range, and it totally interfered with the ability of the cashiers to check product out. They had to remove that lighting. So there are other kinds of interference, not just in your health, that can show up in lighting that appears to have low flicker even to the eye. And that can in some cases affect industrial equipment. The interesting thing about LED lighting, and actually historically beginning with the magnetically ballasted lighting, is that there was a fraction of flicker which got better once we went to electronically ballasted fluorescent. And strangely, it kind of took a step back with LEDs. And the reason for that is twofold. Really, the LEDs are extremely responsive, much more so than the longer persistence of the phosphors in fluorescent lighting. And so high frequency electronic ballast in fluorescent, those effects didn't really come through to the extent they can with LEDs. And LEDs have experienced an incredibly rapid drop in cost. And that pricing pressure often entices engineers and vendors to reduce cost on the electronic side. And often that translates into reducing the amount of current filtering and therefore the quality of the light that ends up coming out of the LEDs. And of course, this is what we're talking about here, but it's actually been a more noticeable problem with LEDs than in the past. And of course, incandescent, by virtue of the physics of a hot filament, has had fairly low flicker, 10% or less, depending on the type of lamp.
Yeah, it's very interesting to realize that flicker really is at a range of 0 to 100% with LEDs. You can have, not all LED lights are created equally, right? So that's a very great highlight to understanding why LEDs are so important and what questions you should start asking as well.
That's right. They're one of the first technologies where the quality of the light at least temporarily in terms of time, is completely dependent on the quality of the electronics driving it.
Very good. And, this is a perfect time to ask the audience about how they react to flicker. So let's say you walk into a room and suddenly one of the lamps in the fixture above you starts to flicker. What do you do? And as we're getting a couple of these results in, it is very interesting because I think about this myself, and right away I would notice the flickering, and just think, oh my God, this is annoying. I don't know how I can stand going into a conference room with lights. So that's just my personal reaction to flicker, but I am very, I would say, sensitive to it, as are all of our speakers here too. I am going to go ahead and skip to the results now. Please do get your last-minute submissions in, last-second submissions. Okay. A lot of the audience says they turn off the lights and continue working. And it's amazing how it's gotten to that point. People realize that there's flicker. They can't do much about it, so they resort to the option of just turning it off and continue working. And there are some bold few that say they leave the room. They can't stand it anymore. And there are a few after that say nothing, it doesn't bother me at all. So it's very interesting to see the results. Thank you very much for participating. We will go ahead and continue on with how do we verify flicker? Now that we know that flicker and lighting exists and we understand why we should care about it because it does affect our health, our wellness, our safety, even our electronics, the next question really is, well, how do I measure flicker? And when you think of measuring flicker, Naomi, one of the biggest questions is, what are the metrics that we can use to measure flicker?
There are a whole pile of flicker metrics, and unfortunately none of them is complete or works for all situations. So we are hoping to get better metrics available soon. But in the meantime, here's what we have. The IES has two metrics that they've listed. One is percent flicker. You basically look at the waveform, and what you see in the upper right is one cycle of an oscillating light output. Luminance is the vertical axis, and you take the maximum point, you subtract the minimum point in the cycle, and you divide that by the maximum point plus the minimum point in the cycle, and multiply the result by 100%. And that gives you an idea of how much flicker you're getting, and it ranges from 0 to 100. If you've got basically products that are on and then off, on, off, on, off, that's going to be 100% flicker. And it's going to be something less than that if you're going from on to, say, 70% of on, and then back to on, and then 70%. So that's how you calculate the amount of modulation. That metric does not take the shape of the waveform into account. It does not take the duty cycle into account. Duty cycle is just the percentage of time that the light source is on over that cycle. And it also does not take the frequency into account. So, for example, we know that a product that is flickering at 100% is pretty visible at 120 hertz. But if you were to operate that at 2,000 hertz, the likelihood is that you would not be able to see it unless there was extreme movement between you and the light source. So the second metric is flicker index, and that ranges from 0 to 1. It is not as commonly used because it uses something scary, and that's calculus. So it's actually a better metric. It does also not account for frequency, unfortunately, but it does account for the shape and the duty cycle of the light output waveform. So basically you're looking at the area above the average light output, and you're dividing that by the area of the whole waveform, basically area 1 plus area 2 in the denominator. So that's improved, even though it's not used very much. And then there's a third one that was developed by the IEC. It's called the PST metric, also called a flicker meter metric. And that was based on voltage changes and voltage fluctuations that resulted in flicker in an incandescent lamp from public electric supply systems. So if you're running power down to the end of a rural area and you have an incandescent lamp on the very end, how much flicker can that deliver without being annoying to the people living in that house? That's basically where it came from. It ranges from 1 or 2 hertz up to 80 hertz. So that is a metric that has been adopted for use in commercial applications and in roadway applications, for example. Now, the next one was a standard developed by the IEEE, by the P1789 committee. It was published in 2015, and it was really the first metric that took health effects into account. And it is more conservative than some of the others because it's looking at health effects, not visibility of the flicker. It basically plots the percent flicker, or the modulation, which we talked about in the previous slide, and frequency. And there are 2 levels of effect. One is called a no effect level, which means that it should be safe for virtually all populations, and a low risk level, which is safe for the vast majority of populations. It's a very simple metric. Its shortcomings is that it's hard to evaluate complex waveforms, and it doesn't account for the wave shape or low duty cycles. And low duty cycles frequently happen when LEDs are dimmed. The stroboscopic effect visibility measurement, SVM, predicts the visibility of the stroboscopic effect above 80 hertz, and it uses FFT analysis, so it's much more sophisticated. And it's a good metric too, and its shortcomings are that it too is not complete. It has to be combined with another metric, and it's for a fixed gaze only. As soon as you have relative movement between an object and the light source, or your eyes and the light source, you can pick up phantom array effects that actually make that stroboscopic effect more visible. So that's a limitation. It's also doesn't account for the response of very sensitive individuals. It really creates an average observer, a standard observer. So we also don't know whether the SVM flicker visibility correlates to neurological effect. We really need more research, and we really need to get the neurology community involved to help us figure out which metrics would really be more predictive of problems. Mm-hmm. If you've heard about the NEMA 77 2017 standard, that is a combination of PST and SVM. And the advantage that this has is that a group of manufacturers have actually signed on to using this standard as a first step towards reporting flicker and minimizing flicker. So it has some strength in that respect.
I see. So even though some of the most common metrics could be percent flicker or flicker index, those are still lacking in the information, the total information that's provided to the user.
That's right. We have hopes for the future. We all have our fingers and toes and eyes crossed that we're going to get a better metric soon.
Yes, I think we all are then. Okay, well, you know, we've talked about some of the metrics that can be utilized for measuring flicker. John, what do you think about actual flicker measurements, though? How is the audience able to make an actual flicker measurement?
Yes, I think that one of the problems with measuring flicker, as Naomi talked about, is they can get quite complex. And really, it's the waveform that really matters. So how do we, it would be nice if we could combine, say, flicker percent and flicker index and also frequency into some kind of metric, and a lot of work is being done. So what at the present? So what can you do today? And I'm going to describe two methods that you can do. Anybody can do today. First, I wanted to just say that we talked about magnetically ballasted lamps had 40% modulation. We talked about incandescent lamps had less than 10%. And I wish that Edison was, designed the incandescent lamp so that it would have low flicker. It was just blind luck. The mass of the filament keeps the light going while the power goes out. I wish the fluorescent lamp development people, me among them, okay, were designing the discharge so that it would have low flicker. Well, it turns out that if you let the lamp go out on the power line basis, 120 times a second, the efficiency drops, and it gets very hard to restart the lamp every half cycle, so it becomes a nightmare. So for reasons having to do with practical running of the lamp and for getting the maximum efficiency, we really were fortunate when electronics came along to gravitate towards lower flicker levels. So we went from maybe 40% maximum to now typically 10% in terms of flicker percent. We'll take a look at that. So the typical way that you measure flicker is you start out by looking at the waveform as a function of time, and then you can do all sorts of measurements on it. And what I'd like to start with first, though, is to kind of back up and say, can we actually visualize this flicker, which is invisible to the eye, right? That's not apparent to the eye. And it turns out there's a very simple way to do it. And anybody who has a smartphone, pretty much anybody who has a smartphone, has one that has a slow motion feature that will capture a scene at 240 frames per second and allow you to play it back, say, at 60 frames a second. So you can take something that's happening quickly and you can slow it down. That's the whole idea of slow motion. If you do that twice, you can get it to operate very slowly, okay? But even once, one picture with your smartphone will show you a rapidly changing light bulb, light output, as a function of time. In other words, suddenly what was invisible becomes readily visible. And Naomi, I don't know, or not Naomi, but Yumi, I think I need you to actually run the video. So what we're going to do is to take a look. We're going to take a look in a second at 3 light bulbs where we just basically pointed a smartphone in the slow motion mode and then played it back a lot slower at 2.5 hertz. Now you can actually see the light changing output. And we see, the flicker percent is like 50% for the middle one. It's less than 1%, so you see no change for the one on the left. And it's, I think it's about, I'm sorry, it was 60% and 50%. Mm-hmm. This method, which works for anybody with a smartphone, and that basically is anybody today, will allow you to, one, get a feeling for the percentage, the amount that it's changing, and two, get a feeling for how much energy is involved in that change. And that's sort of a combination sense of flicker index and flicker percent. Unfortunately, it doesn't tell. Well, you can tell. You can figure out what the rate is by going back and you can calculate the 120 hertz flicker or the 100 hertz flicker depending upon where you are in the world, and you can see that in the flickering lights. But it's really useful for line frequencies. In other words, the 120 hertz and the 60 hertz. If you have half wave modulation, and 100 hertz and 50 hertz modulation. It really allows you to see what your eyes and brain are actually being subjected to. And as Naomi talked about earlier, this really can be particularly problematical in fairly simple tasks like reading can cause problems. Wilkins reports, right, Professor Arnold Wilkins, who's quoted in the IEEE 1789 report, actually demonstrated that headaches were reduced by a factor of 2 by switching from magnetically ballasted lamps to electronically ballasted lamps. And you see that the flicker percent probably dropped by a factor of 2 when he did that. So if you see pulsing, the flicker level is probably too high for at least a significant subset of the population, as Naomi talked about earlier. Could be a problem. The limitations with this, the advantage of this method is anybody can do it, and I would urge you to try it. Limitations are that basically you're tied to how fast your smartphone operates. The 240 frames per second will allow you to capture the 120 hertz quite well. If you're in an airplane, you'll see something, but it'll be likely to be aliasing because the frequency is like 450 hertz in an airplane. I actually tried it yesterday. Naomi mentioned it, that she's seen stuff with a smartphone, and in fact you see an effect, but it's not like this pulsing effect. So what do you do? What if you want to go to the next step? What if you see some pulsing, for example? How do you compare one light source against another? The 50 and 60% flicker examples that we talked about really weren't very helpful in terms of being able to select one versus the other because they look pretty close. So you can go out and get a laboratory scale measurement system, which we have, or you can build something which is quite helpful and is almost as good with a handheld oscilloscope that you can get from for example Amazon, and a solar cell, which we got from an LED solar-powered landscape light. Very, very simple devices, and provided some custom programming. You can actually calculate percent flicker and possibly flicker index as well, because you'll see that you can actually see the waveform. So what kind of flicker measurements might you see out on light sources? And these measurements that I'm showing in this slide are really laboratory test equipment measurements, and I'll compare it against what we can do in a moment. But you see that for the legacy products, those are the upper three: incandescent, it's a quad tube compact fluorescent lamp, magnetically ballasted, and then a quad tube compact fluorescent lamp that's electronically ballasted. Couple of things to note. First is that the flicker level never goes to 0. So there is deep flicker in the sense that we see 37% and the flicker index is like 0.11. Typically, you'd like the flicker index to be close to 0, 0.00 or 0.02 or something like that. And we have achieved it actually in the electronically ballasted compact fluorescent. That's a completely different story with LEDs. For LEDs, you can actually change the current going to the LED, and in fact, the light will follow it. In fact, so much so that Li-Fi, as opposed to Wi-Fi, is possible using LEDs. You can see that the flicker level can be quite low, and in fact, we're showing 1.7% in the 2x2 troffer, LED troffer. And that's almost all high-frequency modulation leaking from the power supply. However, if you start dimming it, then you can introduce low-frequency flicker that's significant. Here, in this case, 22%, and the flicker index starts building as well. It's taking a significant portion of the duty cycle. So you can see all of these things if you're able to plot the light amplitude as a function of time. And this meter that we're talking about can do exactly that. This is a real measurement. If you notice, I enlarged it for the slide, but it shows 10% flicker, and that's shown actually in the upper right-hand corner. You can see the 10%. And that actually is calculating that on an ongoing basis. The interesting thing here is this is mostly 60 hertz. Even though it's electronically ballasted, the light output is changing with the power line at about a 10% rate. And that's a function of how much energy storage has been selected for the lamp. The very little, if any, right, there's very tiny, you see tiny wiggles on top of that. That's the high frequency that's actually running the discharge. That's not appearing as light output for a number of reasons. And really with LEDs, we can be subjected to high frequency, 100%, 100 kilohertz modulation that Laszlo talked about earlier. That's new. Just a few minutes ago, I was looking at my voice-powered lighting, and I commanded the Google Assistant to go to 50%. And I was watching it on the flicker meter. The flicker went up to over 40%, and it was mostly high frequency, about 1,000 cycles per second, and with about a 50% duty cycle. So it's pulse width modulation. And that's new. That's not something we've done before. So you can see all of that with the flicker meter. And this kind of flicker meter would allow you to put that in the hands of anybody who's interested in seeing what they actually have.
And, now that we, understand what a flicker measurement is, and this goes right into this next slide, what type of, is there any threshold that the audience should be aware of? Are there any flicker limits that are considered non-impactful to our health and wellness? John, why don't you go ahead and take this as well?
Okay, great. Well, as we heard from Naomi, the IES and the CIE and IEEE are all working on trying to develop a simple, coherent measurement and standard to go with that. And there's a lot of progress that's being made. And in fact, there are things going on in California. California, for example, has a criteria, Title 20, for a maximum amount of flicker. In my view, it's a little bit larger than it ought to be, but it is a first stab at that from that point of view. The thing that is interesting to me is it's very clear that the lower the percent flicker value that we have, the lower the flicker, the better. The lower the flicker index value, as we talked about, the better. The higher the frequency, or basically no change, is better for health and wellness. And all of those things are actually achievable, in my view, with the technology that we have today. We haven't really focused on flicker in terms of delivering low flicker levels. And that's something that I think that's a real opportunity for us.
I agree. And, one of the best parts about this conversation is to have an understanding about how we can actually measure flicker in the field. We're learning about the theoretical aspects of flicker and how we can see it graphically, but I'm just going to go to this one slide here where you can actually take a flicker meter, a portable flicker meter even, and just put the oscilloscope up to or the photocell up to the actual light and see a wavelength in front of you. And some flicker meters are more advanced and can provide a percent flicker output so that you can correlate that wavelength to a certain percentage number. And since we are all attending this webinar, one of the things that was announced during all of the emails that were advertising for this webinar was that we would raffle off some flicker meters to all the attendees. So thank you for all the attendees who have joined. You are all part of this raffle. So at this point, we are going to raffle off 2 of the 3 flicker meters we have. So 2 of them will raffle off right now. The very last one will raffle off towards the end of this webinar. And the way we'll raffle this off is everybody is assigned a certain number as they enter the webinar. I'm going to go ahead and ask Naomi to just give me a number from 1 to 75. And according to what number she chooses, I will go ahead and see what number correlates to the name, and I'll announce the winner. So go ahead, Naomi, just 1 to 75.
46.
Okay, give me one moment. Okay, Jim Gaines. Congratulations, Jim Gaines. Our Greg Fleece is actually going to reach out to you right now and just ask you a couple of questions to get your information. You have won one of these flicker meters, and our flicker meter looks exactly like this. The flicker meter measures the percent modulation of light at a range from 0 to 100%, and it provides the user with an accurate visual representation of how much flicker they're being exposed to in real time with a wavelength form of a graph. All right, John, why don't you give me another number from 1 to 75? 15. Great. 15. That's awesome. Get somebody from the beginning. Okay, we've got Chris Campbell. Chris Campbell. Congratulations, Chris. We will again be reaching out to you. And more information on this flicker meter will be presented. We are getting a couple of questions on the meter through our chat, and I think the time will be towards the end of this webinar to discuss a little more about that flicker meter. Thank you, everyone, for registering and attending. We have one more flicker meter to go, so we will be raffling that off towards the end. We are on our last talking topic, and really this is, what can I do about flicker now? Now that we know flicker exists and how much of an impact we've made, and we verified that, yes, we are exposed to some percentage or some index or some amount of flicker, what can we do about that now? Laszlo, what do you think about this topic?
Well, from a general lighting point of view, of course, with LEDs, what you want to do is filter the current that's driving the LEDs to make it as close to ripple-free DC as possible. So I'm introducing a new term here, ripple, And so if there are any engineers listening who are involved with the electronics associated with lighting, we often talk about ripple as in a ripple voltage or maybe a ripple current. And the typical energy storage device in the modern piece of lighting that is used to reduce flicker is the electrolytic capacitor, because it's relatively low cost and it has enough energy storage capacity to help the light ride through the AC cycle where there's no power coming from the power line, and still deliver some of that power to the LEDs. The usual way that flicker is reduced, the least expensive way, up to a point of about 20 or 30% of flicker with LEDs, is to increase the size, either physically or electrically, of this electrolytic capacitor. So some of the higher quality lamps and lighting systems with lower flicker, but that don't completely eliminate it, take this approach. So they add more capacitance or more capacitors to the circuit, which tends to smooth out the ripples in the current that's going to the LEDs. But if you plot out on an engineering basis what it would take to get down to, let's say, 1% with that technique, it turns out not to be cost effective, either in size or in the cost. And so the best way to tackle that is to introduce a second regulator. So what you are doing is taking the ripple that still exists in your energy storage device, in your capacitor, but smoothing that out before that current gets to the LEDs. And ideally, you would smooth it out as much as possible all the way to DC and eliminate the 120 hertz or even higher levels of flicker that are there. And there's more than one way to do it, and of course, that gets into the engineering of these circuits and the various trade-offs you have to make, a cost, size, lifetime, etc. But rolling all of those things up, it turns out that it's not free to eliminate flicker, but it doesn't do anything like double the cost of the electronics. So we at Energy Focus feel it's an important enough issue that we've decided to engineer this into all of our lighting systems. And so we only, at this point, we only manufacture flicker-free systems. And because we think it's an extremely important differentiator for us on a product level, but also just because even if you can't see it, the health effects are becoming so well known and the awareness is increasing. We want to be out ahead of that. So we've gone ahead and made the investment to be flicker-free in our product line. It's worth mentioning, I should have mentioned it on an earlier slide, but it's not just a safety issue with rotating machines and a health impact, but there's other practical situations where high and low frequency flicker come in, and that's things like video conferencing systems or high quality filming. So often it's the case that even if you're filming something on your phone, not in slow motion, with high levels of flicker, it can interfere. And these show up as bands, light and dark zones in your video or in your still photos. And some of you may have seen these. And so there are other reasons to remove flicker even than just that. So as I mentioned, we believe it's worth the investment to remove flicker. And once again, on an engineering level, once you make the commitment to reduce flicker, then the question becomes, well, if you're adding extra circuitry to do it, how low can you take it? And it turns out the good news is, once you make that commitment to add that circuitry, then taking it to a very low level is quite feasible, and in fact doesn't cost any more than, say, reducing it or cutting it in half. So unlike the usual approach, just by increasing the number of capacitors you use, which cuts it down incrementally, but you never quite get down to really, really low levels. With the active control, the active regulation, you can take it down to effectively zero. We say less than 1%, because there are always, there is a price to take it far down below 1%. But at 1%, we feel, or less, we feel the effects are effectively negligible. And we think future studies will and regulations will only lower the acceptable flicker rate. So we'd like to get out ahead of that and just take it down as close to zero as we possibly can. And so what can you as a lighting customer or specifier do? Well, you can take some of these free or low-cost methods like the foam or the portable flicker meter, and check out your lighting in person. I do it wherever I go. In the office that I'm sitting in, the lighting above me is about 30% flicker. I have my own extra zero flicker task lighting that I use to light my desk, but it's everywhere really, and so it pays to measure this kind of thing and to ask for the flicker data from the manufacturers. So you want to be aware of the guidelines and ask for flicker statistics or measures for the lighting that you're buying, and especially, and often you can't get this, but especially for dimming systems, because a system can be designed with little to no flicker in the full-on state, but when you're dimming, or especially dimming deep, the technologies required to get that deep dimming may require some extra modulation that's not there when full-on. And so you want to know what the worst-case dimming is, or the worst-case modulation and flicker is over the entire dimming range. And finally, the best evaluation that you can really have is a third-party measurement of some sort. And there are several ways to get that. UL, though, which is typically a safety body, is starting to measure and certify lighting products for their level of flicker. And they have different levels and measures of certification. One that we get for our products at Energy Focus is less than 1%. But pay careful attention if you see this UL flicker mark, because it doesn't mean that there isn't flicker there. Some of the UL markings are, say, 10% or less than 5%. So they will measure it and allow you to mark the product, but that doesn't mean it's flicker free. So you want to read this labeling if you see it, and use that actual number as part of your basis for making the decision.
Very good, yeah. And this this UL verified mark, that is something that is fairly new into the market. So I'd like to ask the audience, does a UL flicker verification have value to your organization? We are getting a bunch of responses back, and I'll leave it to a couple more seconds just to get the results. But again, does UL flicker verification have value to your organization? More and more with lighting, flicker has become such a topic of conversation, and we are seeing the market change as flicker becomes so independent in itself. So we're seeing UL apply certain regulations, we're seeing IEEE apply certain guidelines to follow, and we're seeing a lot of manufacturers also look into flicker. So it would be interesting to see how much of the audience would like more information from these third-party organizations on flicker. And if we skip to the results, wow, more than 85% say yes, UL flicker verification does have value to your organization. And this is very good feedback to take back, because this is stating that you should be asking about flicker. Flicker should be a topic of conversation and maybe something that should be added to a specification sheet. and maybe a topic of conversation to a manufacturer, especially when you're asking what percentage of flicker do your lights produce. Understand what that number means. And we do have a couple of metrics that we mentioned today that might be tools for you to use now to understand that question better. So thank you, everyone, for providing that insight. This does lead to our Q&A session right on time. And I am just going to take a couple of minutes here. We've gotten plenty of questions. I'm just going to go through some of them, and I will designate some of these questions as well. Just give me a couple minutes. Okay. All right, John, this one I'm going to hand off to you. Ashley from the audience has asked, what does it mean to be at 100% flicker? Does it look like a stroboscopic light?
That's a great question, and I always wondered what it felt like, and I found out the hard way. I went to a hotel. This is hilarious. I was giving a talk to some folks who were school administrators and so forth across the hall. This is in Pasadena. In the hotel, so I was going over my emails and whatnot, and it just felt funny in the room. And this is an upscale hotel. That room turned out, I had a flicker meter with me. I had this little scope, this flicker meter with me. It turned out that hotel room was 100% flicker. And it looked a lot like the LED picture that was 97% that I showed a little earlier. And it felt funny. And I turned off the light. They were eminently controllable. There were iPads and all this stuff. And I found one compact fluorescent light that they hadn't managed to replace, and that's what I used. I just couldn't take it. But I didn't see a stroboscopic effect. The effect that I was getting, I think, was more like what we were seeing, what Dr. Wilkins describes in the work that he's done. Just moving my eyes across the page, it felt labored, and it was better to read at a much lower light level than to put up with it. It was amazing. So you can, I think, if the levels are high enough, I think that you can affect a significant portion of the population and maybe the majority. And in fact, the anecdotal data is people hated magnetically ballasted fluorescent lamps, and in fact, a lot of work has been done beginning in the 80s that say that anecdote turned out to be correct. That getting the number, say below 10% flicker at 120 hertz, that made all the difference. Just in terms of what folks had been subjected to. At least they were back to the kind of incandescent level. So who knows? Now, that doesn't mean they went to zero, right? The number of complaints were reduced. Who knows what would happen if you had flicker levels that were like sunlight, in other words, zero in your offices. Maybe they would disappear even further. Certainly at-risk folks, kids with obviously who have adults who have photosensitive issues. The folks on the autistic scale, those things. I mean, why would you want to risk that?
Right. And then
John,
that is an interesting.
Can I add to that?
Please. Yes, please.
Just so your Ashley understands, 100% flicker, you may not be able to see. It depends on the frequency. So if it's 100% flicker and it's operating at, say, 3,000 hertz, so it's turning on and off 3,000 times per second, chances are you would never see that. And it wouldn't feel any different to be underneath it. However, if it's a lower frequency, I think what John's talking about is more like 120 hertz, which is very common. That's when you're going to start to see it, especially if the duty cycle is low, which means if the light is on only for a part of the cycle and then it's off, if it's on 50% of the cycle and off 50% of the cycle, that's a very visible kind of flicker. So 100% flicker just means it goes to full on to full off, and depending on the frequency and the duty cycle, it may be noticeable, it may make you feel weird, it may make you feel like you're in a stroboscopic demonstration, or you may not notice it at all.
Very good point.
Right. Yeah. Right. If this was the measurement was 120 hertz. This that I was talking about, since I had the meter with me. So I know the frequency. So Naomi's point is very well taken. But believe it or not, there are lots of light bulbs out there in the world, especially these decorative LED bulbs that are pretending to be filaments. Many of those are at 100% flicker. At 120 hertz.
Got it. All right. And Terry asks, and maybe this one is a good one for Naomi, where does the flicker metric included in the California Energy Commission's JA10 index for Title 20 and Title 24 fit with respect to the metrics discussed today?
Basically, JA10 is an analysis method that looks at the frequencies emitted by the product. And if the frequency is higher than 200 hertz, it's not regarded. It's assumed to be fine. The flicker is assumed to be fine. Below 200 hertz, it basically allows anything with 30% flicker or below. That is problematic for people who are affected by magnetically ballasted fluorescent, because fluorescent used to operate at about 27-28% flicker. So that JA10 system is great for eliminating some of the worst flicker. However, it will still allow in things as equivalent to the old magnetically ballasted fluorescent. So it's a start, but it doesn't go quite far enough.
I see. That's some excellent information to know. But it's also, as you mentioned, a great start for the industry. Another question from Dan. I'm going to target this to Laszlo. Dan asks, what can you do to help reduce flicker, if you can, caused by equipment within a space, such as a copy machine, medical equipment, etc.?
Well, unfortunately, there's not much you can do to mitigate interference caused by equipment like that, except maybe to swap it out with other equipment. Now, when you say a copy machine or medical equipment, usually the case there is it's in intermittent use, and sometimes, not always, those pieces of equipment can cause momentary visible aberrations or a flickering of the light. That's probably less harmful because it occurs sporadically, less harmful than the systematic, continuous 120 hertz flicker that would always be there due to the steady variations in the power line. And so I would say the problem of intermittent flicker caused by various pieces of office equipment or whatever That's a less serious thing because it is so intermittent than the systematic flicker. I would like to jump in for a second, Yumi. I noticed somebody asked about LED TV screens and computer monitors.
Yes.
This actually is a huge issue with respect to flicker, and it's not something that Energy Focus is in the business of. But I can tell you just from my own measurements that many LED backlights are dimmed by a high frequency PWM, and there is an issue with the flicker there because in an office setting, you might spend a huge fraction of your day with a monitor that fills a large a portion of your field of view, and depending on how the thing is being dimmed, it might either be full on, in which case there may not be much flicker, but if you dim the screen, or if it dims by itself to try to adjust to the general lighting, you could be exposed to very high frequency flicker, which may not create headaches and so on, but if you're reading a lot, which is what most of us do on a screen, I would say it's something that the industry needs to address, or at least more studies need to be done to quantify that, because it's something that you stare at all day long. And your working surface on your desk, we can address that with the general lighting, but general lighting industries can't really deal with the display ramifications, but it really needs to be looked at.
Yeah, that's a very good point, because this is something that everybody sees daily, almost too much of now, right? So LED screens, video screens, and that will be exposed to flicker to some point. So even if it's not through the lighting on that's coming from your ceiling, flicker can be affecting you in some other ways. I've got another question from Rachel. She's asking, how can I convince my office to make the switch from flickering lights to non-flickering lights? And, I will give this to any of you three to answer this question.
Well, this is John. I'd start with a measurement. If you've got a smartphone, you can show them that there's a problem. You have to. I think that would be the place to start. That there's a problem. If you don't see any pulsing with the smartphone test, it may be that there isn't a problem. That has to do with the design of the lighting, but there may be some other problem that has to do with the power line itself, and there is intermittent problem associated with delivering power to the system. That can happen. You can get power line fluctuations that basically get fed into the lighting system. But I would start with the problem. It's likely that you're right, that the lamps are flickering, as Laszlo was talking about. Since there hasn't, the LED lamps have appeared as fluorescent lamps appeared, as incandescent lamps appeared along the way, and we're measuring the impact of them. LEDs are wonderful. They have tremendous positive features. And because they have these tremendous positive features, for example, the speed of the LED, you could do Li-Fi, for example, with LEDs. You can avoid collisions because because the brakes can come on faster on your LED stoplight. So there are very positive things associated with even the speed of LEDs. But so this is something we don't have to have, and we just should become aware of it. So I'm with you. So I'd say start with measuring it.
I think that's an excellent place to start as well, because then when you know you have a problem, you can prove that you have this problem. And if it's one spot in your office, it could be multiple. So completely agree there. At this point, there are a couple more questions, and we'll answer those questions individually to you. If not on this chat box, we will go ahead and reach out to you in person via email. But one of the last questions I wanted to present to all three speakers who are just brilliant with their information on Flickr today. Thank you very much, all three of you, for attending. But I just wanted to ask you three, and we'll start with John. What is the most important idea you want our audience to take out of this webinar?
Well, I guess my view is that why wait? Flickr is something that we can make effectively zero by design. I'll call it by design. It may cost us a little bit, but by design we can effectively make it zero, including dimming. It's a matter, as Laszlo has explained to me many times. It's a choice that we make and that we should make. So I think that's the thing I'd like to, my takeaway is that we don't have to have lamps that exhibit flicker. Maybe when we had fluorescent lamps and the only way to ballast them was magnetically, we had to put up with flicker because the power line was sitting there. But now we have electronics, and the electronics can really basically make the light going to the LEDs or the current going to the LEDs a constant, and therefore the light coming out of them a constant. That means we don't have to have flicker.
I like that very much.
So we don't need to. We don't need to wait for all of the data to come in.
I'll also add to that there is a large government building here in Portland that had an energy retrofit of their lighting about 3 years ago. One of the products put in was a T8 LED replacement tube, and employees started noticing flicker and complaining about it and continuing to complain about it, and this entire building is now going to be retrofitted again in order to get rid of the flicker, and it's very expensive. So if you are specifying products or retrofitting fixtures with LED products, do your homework, make sure the system does not produce flicker way before you place the order. Otherwise, it'll cost you a lot of money and reputation.
Yeah, I mean that is one big headache in all forms of the definition headache. But it is a point well made. Why wait when the sources of information is really in your hands as a manufacturer, but also as the customer. Laszlo, I'm going to ask you the same question. What is the most important idea you want our audience to take out of this webinar?
I would say it's like this. This flicker, especially the systematic high-frequency flicker, is easy to spot with your phone, and you should do it. Learn how to use the slow motion feature on your phone and make a simple assessment of the lighting around you. And then seek out that kind of lighting that is extremely low flicker. Energy Focus has essentially done its best to engineer it all the way down to less than 1%, which we feel is an acceptable limit. So I would say, one, measure it, and the other important idea is the science is still evolving and being refined. It's known to be an issue, but the question I'm asked whenever this topic comes up is how much flicker is okay and how much isn't. And I would say the honest answer is it depends on who you are, it depends on your physiology, and we're not really 100% sure. So why chance it? When it's not that much more expensive, buy the lighting that has the lowest possible flicker specified and play it safe. Those are the two things that I would recommend.
Very good. And Naomi, what is the most important idea you want our audience to take out of this webinar from your perspective?
Oh, please, I would like to retire, but I can't retire until I've eliminated flicker from the LEDs in this world. So please fix the flicker so that I can retire.
Point made. Not all LED tubes are made equally.
Honestly, I'm one of those people that's very sensitive to it, and it drives me bonkers. So I just want to eliminate flicker for everybody.
Very good. And you know, every single topic that we spoke about during today's webinar does drive the fact, and John, you mentioned it earlier, that the control is really ours, and ours could be defined as the manufacturer who is producing these flicker-free solutions, or the specifier who specifies and says, I want 0% flicker. I want as close to 0% flicker. That control really is ours. At this point, I would like to go ahead and, before I forget, raffle off the very last flicker meter. And again, I've gotten a bunch of questions, and I'll answer them right now. These flicker meters are designed by Energy Focus. We have designed them in-house, and they do output percent flicker. Laszlo, I'm going to ask you for a number between 1 to 60 this time. Go ahead.
Well, that's a problem, Yumi, because I've already selected 66. So.
Oh no, no, we can't do 66 at this point.
All right, let's try 33 then.
Okay, 33. All right, congratulations, Sarah Pennington. You have won the very last flicker meter. This is a great point to talk about. If you are looking for flicker meters, there are many places that you can go to. Energy Focus is looking to sell these flicker meters as well. Please do reach out to us if you have any questions about that. Sarah, Greg is going to reach out to you via chat, or you can respond to us via email as well with your information so we can mail these flicker meters out. Congratulations, Jim, Sarah, and Chris. This webinar really does focus on what you, the audience, can do about flicker. And one of the biggest things that you can do about flicker is to understand flicker. And this is one of the biggest steps that you're taking right now to understand flicker, to understand the metrics, how it affects us, why it exists in general. So thank you very much, everybody, for attending this webinar. I hope that we provided you with a lot of information to start your, the next best picking out there, of all the solutions, of all the lighting solutions there, which there are many of. So it's important to ask the right questions and do your research, and know that there are solutions that produce 0 or close to 0% flicker. And those solutions are the best for your end users, whether you're a manufacturer or whether you're the specifier. If you have any questions, feel free to contact Energy Focus. You do have our contact information, and as well as our email and our website. Thank you very much for attending this webinar. And I would also like to thank the 3 speakers, Laszlo, John, and Naomi. Thank you so much for being a part of this. As a reminder, you will receive a copy of the slides, and this recording will be made available in the next couple of days. You will get an email follow-up from that. Thank you, everyone. This does conclude this webinar.